This is a short video of some information that's embedded in my first stockpot refining video, part 1. It's about the reactivity series of metals, and I decided to pull the information up and make a separate video. This information is so important to understand and know as a precious metals refiner. So here we go. Reactivity series of metals. What I'd like to do is talk a little bit about the reactivity series of metals. I've prepared a chart here with all the metals in this reactivity series. In this list, the metals that I work with in my refining mostly are zinc, iron, there's some nickel in there, tin and lead, of course, when we do gold-filled scrap. Copper is a big one. Tungsten I don't see very much. We could see tungsten if we did some contacts that contain silver with tungsten backs on them, but I've never done those, so I don't see much tungsten in my refining experience here. I don't see much mercury, but down here, the precious metals, we got silver, gold, and platinum. Now, according to this series of metals here, the metals up here are highly reactive. In fact, if you took potassium or sodium and threw those metals into some water, they'd react violently and explosively. So these are the most reactive metals up here. As we go down the list, the metals become less and less reactive until we get all the way down here to gold and platinum, which are very, very unreactive. These are very stable elements. If you'll take a look at this here, this text says that a metal can displace any of the metals which are lower in the series. Now what that means is, I'll give you an example. I keep my stock pot full of copper. If you look down here at copper, it's way down here in this list. So if I put any metals in solution in my stock pot that's full of copper, these metals down here will cement out onto the copper as a black powder. That's the powder that we'll be dealing with today. If there's any of these metals above copper in solution, those metals will not cement out. They will stay in solution. So what I'll do is I'll get an effective separation of the metals below copper. They will come out of solution and fall to the bottom of the stock pot as a black powder. These metals up here will stay in solution. If you notice, I have iron higher up in this list, and my waste treatment bucket is full of iron. So the process goes like this. The precious metals waste from my refining go into my stock pot that's full of copper. In the stock pot, the copper and any trace amounts of precious metals, they trade places. The precious metals will come out of solution onto the copper, and the copper will go into solution. So when that reaction is complete, what I'll have is these metals precipitated out as a black powder and the copper in solution. I'll have a concentrated solution of copper with these metals forming a black powder and falling to the bottom of the stock pot. Once the reaction is complete in the stock pot, and I'm certain that all the precious metals have cemented out onto the copper, what I do is I take the stock pot, set it off to the side, and allow it to settle for several days. Then I siphon this copper solution into my waste treatment bucket that's full of iron. In the waste treatment bucket, any metal below iron, including the precious metals, but any metal below iron, the cobalt, nickel, tin, lead, and copper, will cement out onto the iron as metallic particles that fall to the bottom of that bucket, and the iron goes into solution. And what I'll end up with is a bucket full of iron in solution with all these metals below it cemented out. It is very important for any refiner at any level to be very familiar with this reactivity series of metals. Understanding how this works is the basis of some of the refining techniques that we use to separate precious metals from base metals. If you remember, in my stockpot refining series of videos, I think I had 16 videos in that series, and I was trying to get the copper separated from the platinum group metals and gold that was in my stockpot. I had all four of those metals in solution together in my stockpot, and I tried to use zinc, which is way high up in the reactivity series of metals. And when I used that zinc, it cemented everything out under zinc, including the copper with the platinum group metals and gold. And the copper cements out as a black powder and looks identical to those other precious metals that cement out. So it was a very difficult time for me to try to get that copper away from those platinum group metals. Well, in the next series of shots here, what I've done is I think I've come across a method whereby I can use copper powder to remove the copper from the platinum group metals that are in the solution. And well, here, just watch these next few shots here and you'll see what I'm talking about. I'm using the reactivity series of metals to separate the copper from the platinum group metals. I wanted to share this on video. I think I've made a nice important discovery here. What I have here is some copper powder, finely divided copper powder. What I have in here is some platinum group metals, palladium, platinum, and copper in solution. In my stockpot refining series, I used zinc to get the platinum group metals out of the solution, but the zinc also precipitated out the copper. What I've done here is I've added a few drops of nitric acid to it, just a little bit, and then sprinkled copper powder in here. And what will happen here is the platinum group metals will cement out on the copper powder. The copper will go into solution along with the other copper that's already in solution in this mixture here. But the platinum group metals will come out of solution on the copper. And if you remember in my stockpot series, I had a difficult time getting rid of the copper. I think this is the way to go right here, is using copper powder. I read this on the goldrefiningforum.com. There's a refiner on there, his name is Four Metals, and I think in one of his posts or in someone else's post, they posted that Four Metals had helped them get their platinum group metals out of solution by adding powdered copper. And that never crossed my mind, so we're going to see how this works. This has been on stirring. I got it on low heat and stirring, and I'm adding small scoops of copper powder to this solution. This is platinum group metals and copper that I had left over from my stockpot refining series, quite a bit actually. So in a minute we're going to take some of this solution out of here and see what we got for the amount of platinum group metals that we got to cement out with that powdered copper. this test here of this solution. Oh my goodness, that is light way up. That used to be much darker brown. Stands chloride on this. Earlier when I checked this, that test turned my test to black. What that means is the copper powder is getting these platinum group metals to come out of solution. Alright, I can't wait any longer. I think I see material down on the bottom. What I'm going to do, turn the stirrer off. I'm just going to pour this liquid off. That looks much different than when I started. That is unbelievable, man. Look at that. That's a good amount right there. Probably a gram or two, but I mean, shoot, man. And it shouldn't have any copper in it. Fantastic. This is all platinum group metals, man. Look at that. That is a good, nice amount there. Beautiful. Here's a look at the material in the sunlight. That's my stir bar down in the bottom down there. Got to get that out of there. But this certainly does look promising. I don't know. I won't know until I process it further and try to extract the individual metals, the individual platinum group metals out of there. Okay, I think I'm on to something here. For the next time I do my stock pot, that looks promising as a way to get the copper away from those platinum group metals. It illustrates how important it is for any refiner at any level to understand how these metals interact with each other when they're in solution. The Reactivity Series of metals, an indispensable tool in our refining toolkit. Thanks for watching.